YouTube, what's up? We're back with another video. I think this lab and a couple more, and we're gonna be done with this series of labs. Unless you guys want to see more, of course. But for now, this lab that we're gonna be doing here is gonna be for policy-based routing. So, I've been having sneezing all day. What this lab is gonna show is the importance of policy-based routing. So, in an enterprise environment or even in a small environment, you might need sites to be more resilient than with just one ISP. So whenever you start working, you will see that some sites are going to have two ISPs, maybe even three, I don't know. But for this example, we're going to be doing two, ISP-A and ISP-B. So basically what we're going to do is we're going to show how traffic is prioritized through ISP-A, for example. That would be the example of the main ISP at the given time. And then we're going to use policy-based routing to divert that traffic for whatever reason, if needed to ISP-B. Let's say ISP-A is down, or ISP-A is being slow for whatever reason, you could do policy-based routing to activate that. IP SLA can kind of also go hand in hand with policy-based routing, but that's not going to be for this video. IP SLA, just to touch on it briefly, could be used to detect the things automatically and use policy-based routing to activate it automatically. Policy-based routing in this lab is going to be something more manual, but again, we're going to be showing an example from PC1, doing a trace route to the internet and you're going to see it go through ISP-A, and then once we do policy-based routing, you're going to see how it goes through ISP-B. And all policy-based routing is match and set. So you match whatever IP address you want to use, and then you're going to set the next hop. So as you can see, everything's starting to come up here. So first things first, let's start from left to right in the configuration. So here we go. Let's see, are we recording? Yes, we are. Alright, so we're going to go into PC1. We're going to go into config, and we're going to give it the host name, PC1. Interface gig 1, IP address, we're going to give it 192.168.10.50, 255.255.255.0. We're going to do a no shut, and then we're going to exit out of there, and then we're going to do a static route to the gateway, which is going to be on router 1. So IP route 0.0, boom, to 192.168.10.1. Exit. You can write that if you want. And then on the switch, still booting up. The switch, we're really not gonna do nothing besides just give it a host name. So conft host name switch 1. Alright, boom. Now we're gonna move to router 1. Alright, boom, enable. So router 1, Jesus Christ. I hate that when I don't do the command to avoid that. Now this thing's going to take forever to boot up. So since I know it's going to take forever, let's go to ISP and then we'll circle back to router 1. Alright, ISP-A, conft host name ISP-A. Interface gig 1, we're going to give it IP address 10.10.10.2, 255.255.255.252, no shut, exit. Now we're going to go to the interface gig 2 of that, and we're going to give it IP address 100.100.100.1 with that same /30. Boom, no shut, exit, and now we're gonna go into OSPF. So router OSPF 1. We're gonna advertise the networks 10.10.10.0, 0.0.0.0.3. We're gonna put it on area 0, make it simple. Let's see, the other network is gonna be that 100 with that .3 wildcard mask. Boom, exit. Let's just do a do right. Exit out of there. Let's see if router 1 is ready. It is. So let's go back to router 1. Boom. time. Hostname R1. Interface gig 1. And that's going to be the gateway address that we were talking about earlier, 192.168.10.1, 255.255.255.0. Going to do a no shut. Let's move on to the other interface, gig 2, IP address 10.10.10.1, 255.252. Guys, I like going through the whole config manually because, again, my complaint when I watch tutorial videos or labs is that they'll skip the config. So I just want you guys to go through it. You can feel free to put this on 2x speed if you want, but I'm going to go through the whole config in case anybody needs help doing the config and not get confused. Alright. Did I no shut that? No, I didn't. Boom. No shut, exit, interface, gig 3. IP address 2020 .1 255.255.255.252. No shut on that. Exit, and then we're gonna go into OSPF. Router OSPF 1 network 10.10.10. 0 255 area 0 network 20.20.20.0 area 0. Boom. And one more network 192.168.10.0. Boom, area 0 exit. You can do a do right, save it. Boom. What's left? We just got ISPB left and internet, so let's keep going. Boom, ISPB. Where you at? Alright, ISPB. Boom. Hostname, ISPB. Interface, gig 1. 20.20.20.2. Look at me going too fast. Slow down, boy. No shut. Exit. Interface. Gig 2. IP address 200.1/30. No shut. Exit. Now going to router OSPF. Advertise the networks. More network to advertise here. 0. Alright, and now the last one, we almost there. Internet router. This is gonna obviously resemble the internet. Let me stop this and wipe it, because that had a config from another lab that I was doing on there. Well, let me start this. Sometimes you gotta go like this. Alright, so the internet one is ready. Let's go into config mode. Boom, hostname, internet, interface, gig 2, IP address 100.100.100.2. Boom, no shut on that. Let's go to the other interface. Interface gig 1. IP address 200.200.200.2. Bro, funny story before I keep going. I had first done this like the very first time. And for whatever reason, instead of making this 200.200, I had made it 100, 100, 200. And I was troubleshooting for like a good 10, 15 minutes until I realized why a loop was occurring even after the fact I did policy-based routing. And it was because I had the wrong IP address and it couldn't go from gig 2 to the internet. It was going all the way back to ISPA. But I just want to share that because it's funny how one little thing can, mess up the whole plan of what you're trying to do. Which is, again, why I like going step by step into the configs to prevent anybody getting confused. Oh, should. We're gonna do that loop back 0, and we're gonna give it IP address 8.8. Boom. Like, let's do a no shut to be safe, even though you don't need to do it really for loopbacks. OSPF network 8.8. Jesus. Network 8.8.8. 0.0. Area 0. Network 100.2.0.0.0. Area 0. 200. Area 0. Boom. Exit. Alright, so before we do the access list to highlight how it's gonna switch from ISP A to ISPB, let's first do a trace route from PC1 to the internet. But before we do a trace route and get stuck in an endless loop, let's make sure this thing works. So can I ping the 100.100.2? I can. Can I ping the 200.200.2? I can. Alright, so let's go ahead and do a trace route to the internet. Alright? So bada bing, bada boom. We should, in theory, see this go from PC1, from R1 to ISPA to the internet. So let's see what happens. Let's go, let's go, let's go. Hey, if you guys have enjoyed the video so far, please smash that like button and check out the playlist for some other labs we've done as well. I think it's called like CCNP Labs, the playlist. Almost done. So 10.10.2, remember that it's on ISPA, right? So we just verified with this trace route that it's going from PC1 to ISPA to the internet, right? So let's say, again, ISPA is being slow, it's down. We need to move traffic to ISPB. This is what we're going to do. So we're going to go on R1, and we're going to make an access list to capture that traffic. And from that, we're going to use a route map to set it to the next hop. All right? So boom. Access list 100, real simple, permit IP 192.168.10.0, which is basically the whole network from R1 inside, so the internal network really. So boom, 0.0.255, go into any. So boom, real simple. Now we're gonna do a route map, clients, or we can name it internal to internet. Boom. Now we're gonna do match IP address 100, and then we're gonna set the next hop, which is gonna be the ISPV. So I set IP next hop. Boom, 20.20.20.2. Exit out of there, and now it's not enough to just do the access list and the route map. You also have to apply it on the actual interface. So interface gig 1, IP policy, route map, what did I call it? Internal to internet. Yep. Boom. So that's really all you need. You see how simple that was? That's all you need. You need an access list, you need a route map to match the access list, set the next hop, and then you need to apply the policy route map on the interface. So let's go back to PC1. Now we're gonna trace route the internet again. So if everything works as intended, no loops, nothing, it should just go straight to ISPB and the internet. So let's see. Boom, hits the router, R1. Should see it go to 20. Yup, 20.20.20.2, which is the next hop that we told it to take. And then this should go straight to that internet. Boom, yup. 200 is on the internet router. So basically real simple, guys. Hopefully you guys kind of grasp the concept a little bit more, why we use policy-based routing, and when to use it. If you ever get a job or work alongside any network person, they're going to tell you they've probably done this quite a bit. Again, guys, if you guys enjoyed this video, please smash that like button. I'm going to make sure to do a couple more labs to show you guys. And again, if you're enjoying the labs, check out the labs playlist. I think it's called CCNP Labs. I'll check you guys on the next one.